Hi class, today we're going to be discussing ionic and molecular compounds. Right now it's going to be ions for this first chapter of 6.1. So ions, atoms either lose, gain, or share electrons to acquire an octet. An octet means 8. It wants to surround itself with 8 valence electrons. And they will either lose them, such as metals will lose electrons to take the noble configuration, or they will gain electrons to take the nearest noble configuration for nonmetals. So right now, we're going to be discussing ionic compounds. Now, ionic compounds, they are ions. Ions means that it is imbalanced of protons and electrons. Depending on which it has more of, that determines the charge. These bonds, for instance, sodium chloride, sodium is a metal and chlorine is a nonmetal, but yet these are bonded together because of the difference in charges. Over here is molecular compounds. These share electrons. That's what the word covalent means. They share electrons in order to make an octet. We're not going to discuss these right now. We're looking at this side. So how does this happen? So ionic bonds occur when valence electrons of a metal, that is the group number, not concerning, we're not involving transition metals right now, lose their electrons based on the group number. And they will transfer them to a nonmetal that will take them, and that positive charge on the one element and the negative charge on the other will create a very strong electrostatic attraction, and we call that an ionic bond. So M is the metal, it will lose the electron. In this case, it's one electron, so it means it's a group 1, and it will give it to a nonmetal that has one space open to take that. And because now the protons outnumber the electrons, this becomes a positive. And this one has electrons that outnumber the protons, and it becomes a negative. Covalent bonds, on the other hand, share electrons. So if there's a space open for a nonmetal and there's a space open for a nonmetal, they will come together. And if you count 2, 4, 6, 8, this has 8 electrons around it. This one's 2, 4, 6, 8. This one also has 8 electrons, but yet they're sharing 2 in the middle to allow this covalent bond to occur. But again, we're not coming to that one yet, but it is referenced here, so you should know about it. So positive ions, loss of electrons. That means that the protons outnumber the electrons. In ionic bonding, ions form atoms when they gain or lose valence electrons. By now, you should have some idea about valence electrons and group numbers. So metals, in a previous chapter, I had discussed ionization energies. Ionization energy is the energy needed to remove valence electrons from an atom or element. Either one you want to call it. For metals, and some metals have higher ionization energies than others, some have very low ionization energies. Excuse me. Group 1, Group 2, and Group 3 will lose that number of valence electrons. It will lose them to take the noble gas configuration prior, so it'll take the period above it, which I'll show you. So because they have very low ionization energies, it doesn't take much energy to remove these valence electrons. They want to remove them. It makes them very stable by actually losing them. So when they lose them, that's when they have a charge to them. They are now ions. So when you hear the term ion, ion is a general term for an element / atom, means the same, that has it's not balanced. When it's a neutral atom, it has the same number of protons, same number of electrons. The term ion means that there's some that's not balanced. So either you have more electrons, which makes it negative, or you have more protons, which makes it positive. We don't know. The word ion just means that there's an imbalance, but it doesn't tell you which way it is. If you wanted to be specific, you would call this a cation. A cation means positive. It's a positively charged ion. So if you use the word ion, ion's generic, just means imbalance of electrons. Cation means specifically that there are more protons than electrons, and that's what you would use to describe metals that have lost electrons. So here I found this on the internet, and this is the valence numbers are matching to the group numbers. So here we have group 1, group 2. So this means everything here has a valence electron of 1. This has a valence electron of 2. This has a valence electron of 3. And 4 has valence electrons, but when you get to this is usually covalent. Carbon compounds, for this chemistry, we share electrons. So I'm not going to really even touch it. That's why it's in blue. What this means is that this loses 1 electron. This loses 2 electrons. This loses 3 electrons. I'm not going to discuss this here. There are some, yes, these are some that will lose some electrons, but we're not going to discuss them at this moment. And I will cover the nonmetals in a minute. So what this means is that, let's say sodium. Sodium has a valence electron of 1. It loses 1 electron. So when it loses this electron, it now goes from an atomic number of 11, that's with 11 protons and 11 electrons, to the configuration of neon. Neon has a filled octet. It involves the S's and the P's in order to fill it up, and that equals 8. It has 8 electrons around it, and now sodium does too. When it loses its outer layer, it actually has a filled octet. We do not draw that. We only draw a plus sign, but it has a filled octet, and it's one of these, just, you have to know about chemistry that it's filled with an octet, but it has a positive sign to it. So all of these, that's what happens. Potassium will lose it, and it will take the noble configuration of argon. It'll have a positive charge because it has more protons, but it'll have a filled octet by the argon. So all of these will take a step up and across when it loses that electron. Same thing for group 2. Anything here will lose 2 electrons, and it'll take, so magnesium will lose 2 electrons because it's a group 2, and it will take the neon configuration as well. So all of these strive for this. Group 3 will do the same. Aluminum is one that it's in the transition metals. However, it only has 1 oxidation state. A lot of these have different oxidation states, like, for instance, what does that mean? It means that iron, this is iron, has 2 oxidation states. It's either a +2 or it's a +3. And a lot of these have it, and they're all over the place. Like vanadium has an oxidation state of 2, 3, 4, 5, I believe. So that's why we don't discuss them right now. Aluminum is a +3. It will lose 3 electrons to take the neon configuration. So that one's usually grouped in just because it has 1 oxidation state and it doesn't change from that. So what is the key thing you need to remember here? Metals, everything in white is a metal. Metals lose electrons, and based on the group number, not concerning right here, will lose that many electrons to make a noble configuration of the period above it, and it has a filled electron. But an ion has to have a plus charge to it. You have to write a plus sign in order for it to be known as an ion. If you don't do this, it is wrong. You are saying it's a neutral atom, and it's not. So here is an overall of everything to help you understand. So this is sodium. Sodium is a Lewis dot structure, has 1 valence electron here, and it has 11 protons and 11 electrons. Here is the electron configuration for sodium, which is 11. If you add these up, it equals 11. What happens is that it will lose 1 valence electron because the group number is 1. And when it does, you see this big purple, how small it is now because it lost that outer layer, that outer level when the 1 electron left. So it's like knocking a whole floor off of your house. It's now smaller, and that's because the pool that it's gone. So electrons can be held closer to the nucleus, but you don't need to worry about that. Just know that the size goes down. It now has 11 protons, 10 electrons, and you have to now indicate, you absolutely have to indicate this is an ion and not a neutral atom. So how do you do that? Well, let's look at the first part. Electron configuration, you have to remove this 3s. It's not there anymore. It has 10 electrons. The key word here is electron configuration. So this is concerning electrons. Everything we do in chemistry has to do with electrons for this chemistry. So you will have to knock that one off, and it will now have the electron configuration of neon, which you could put in abbreviated Ne if you had to, which I'm not sure if we've covered that or not yet, which we haven't. I just realized. Now, on this side, This is a Lewis dot structure, and it has one dot equaling one valence electron. When that goes away, as you see here, you have to account for that because of the fact that this has more protons than electrons, and that's what you should look for if you get confused. Write out the atom, write out the atomic number, and then write out how many electrons it has. The number that is the largest will tell you which way it's going to go. This is protons, that means positive. So this is going to have a positive charge with it. If you had more electrons, then you would have a negative charge, which we haven't covered yet, but that's what you would do. So in this case, you write a plus sign. Now I wrote it down here. If we were in person, I would ding you if you wrote this wrong. There's a lot of things in chemistry that have to be written correctly, and I'm really a stickler for it. For instance, these twos are superscript. They're not next to it because that would make them coefficients in the front. They are small and they're written half above. Same thing here. This is wrong and I would mark it wrong. I don't care that you gave me the element. You did not write it correctly. This is telling me that sodium is being added to something. This is telling me it's an ion. So it would have to be above. I realize we're not in person, so you kind of get away with this, but you should absolutely know how to write it right. So in this case, it's a superscript at top, and you would refer to this now. This is a sodium atom. That's a neutral atom. You cannot refer to this as neutral anymore. You have to speak about it as an ion. So you can't say, so sodium, the element name doesn't change, but you would refer to it as a sodium ion or a sodium cation. Sodium ion, you would have to know it's a positive. Doesn't tell you how many, but it tells you it's a positive charged ion. Sodium cation also tells you it's a positive, sodium ion just tells you it's a charged ion, but you don't know if it's negative or positive. You would have to know that based on knowing sodium. Sodium cation gives you more information. This tells you it's a positively charged ion. And again, don't write it like this. So now we look at magnesium. Same information here. We have proton is 12, electrons is 12, so this is atomic number of 12. We have a Lewis dot structure of 2 dots because this is a group 2 metal. It will lose 2 valence electrons. And to take on the, I believe it's neon. Yeah, it's right here next to it. So it'll take on the neon configuration as well. So electron configuration for a neutral atom, it will show the 2 here. But when you remove the 2 electrons, it's been kicked out. It'll also take the neon configuration. Excuse me. So now you see here, it's larger. When it loses that that last outer layer or a floor in a house, it's now smaller because that outer level is no longer there. Same rules apply. You would call this a magnesium ion, a magnesium cation, and you would write it with a 2+ charge. And now when you write this is again, I'm a stickler for. When you discuss the charge, you can write it with a +2. But when you write it with the number first and then the charge, always. I would ding for this too, because this is how certain things have to be written a certain way for people to understand them. It may not make sense to you guys because you're just learning, but as you progress in chemistry, if you choose to, you have to, obviously you guys are taking this course because you have to. It's part of your core, your road to finish your education. Certain subjects you don't take shortcuts on. And if this ever comes up, you want to write as if you actually know what you're talking about. So if you do not write things correctly, people are going to know that you may not know as much as you should have from that course. These are things that people pay attention to if they know what they're talking about. And I want you to learn the correct way of doing things. So it's a 2 and a plus charge. With sodium, we never write a 1. It's kind of a default. So when you see the plus charge, that's known as 1+. We never write it. It's just known that that's what it means. It means here a +1, but we write it with just a plus. Magnesium, we write the 2 and then a plus, but we refer to the ionic charge as a +2. So it's a little weird with little things. You just have to know them. This is why chemistry can be difficult for some people. It's the little things that you're expected to know and retain. And unfortunately, it's just the way it is. Negative ions. So now we are going to the non-metal side. It's important for you if you get stuck. Ask yourself, it's a metal or if it's a nonmetal. That will then determine what's going to happen next. We are now on nonmetals, and nonmetals take electrons. So those electrons that go away from the metal, they get added to the nonmetal. So in this case, think of it as a floor, and you have construction on it, and you just finished the last bedroom. We're not adding a new level. This is staying on the same level, but you've now finished that house construction or whatever. I'm trying to think of a good analogy. These have very high ionization energies because nonmetals do not give up electrons very easily. They will take them, but you cannot get them away from them. They want to hold on to them as much as possible. So what does that mean? It means that you would have to put a ridiculous amount of energy to remove one electron. And it's made that way so that they will not have that happen. They readily take electrons. That's what they want to do. They want to take electrons away from metals. So when they gain electrons, they will gain the same amount that they need to fill an octet, which is the nearest noble gas to them. So unlike metals that will jump up a period, these will stay on the same floor, but they will take as many as they need to get to that noble octet. So it's kind of like a board game. If they need 2, they're going to jump 2 spaces to get to that noble gas. And I'll show you what I mean right now. So ion, again, is just a general term. But if you call it an anion, that means that it is a negatively charged ion. Something different comes with an anion, though. When we take electrons, when a nonmetal takes electrons, it changes the name slightly. And that's how you know that something has happened to it. So you've never heard of sodium chlorine. We do not refer to sodium chlorine because that's not what it is. It's sodium chloride. And we change the ending of the INE, which is here. We know this is chlorine on the periodic table. It is changed to "ide" when it now has a reaction to it. So it's taken on these electrons from a metal. It is now chloride. It's an ion. So that's when, if you get stuck on this, remember sodium chloride. We refer to chloride, not chlorine. Sodium chlorine is not something we know. We know it as sodium chloride. All right, so here we are at this periodic table I found online, and now hopefully this will make more sense. So again, if we look at the first group, that's group 1, and at the bottom tells you it loses 1. Group 2 matches 2, and at the bottom tells you it loses 2. These are metals. But as we go across, we start getting into the yellow. The yellow is the nonmetals. Noble octet is 8. These are, they don't like to be dealt with. They want to be left alone. So they're at a party where they don't want to talk to anybody. That's how stable they are. Everything is aspiring to get to this noble configuration. So unlike the sodium that loses 1 and then it takes the neon, these all take the same floor. So it's the same floor in a house. They are adding a bedroom if you want. So again, like a board game, they will jump 1, 2, 3. They will take the argon on phosphorus will take the argon. Nitrogen will do 1, 2, 3. It wants to be neon configuration, so it'll take 3 steps if that's how you want to mean it. But steps are actually electrons. It will take that many to get to the noble configuration. Why? Because it has a group of 5. So it means it already has 5 electrons around it. How many does it need to get to an octet? Like a board game. 1, 2, 3. It needs 3. 3 electrons. Electrons have a negative charge. So if you add 1, it now has 1 charge. Add 2, 2 charge. 3, 3 charge. So don't get caught up with the negative and the positive in front of these. Know the number. 5 plus 3 equals 8. 6 plus 2 equals 8. 7 plus 1 equals 8. So all of these will take 1 electron, and it will take the neon configuration, the noble configuration of whatever's next to it. This will take 2 electrons, and it'll take the electron configuration of whatever noble gas is there. This will take 3 electrons, and it'll take the noble configuration of what's next to it. Now, because these are nonmetals and electrons have a charge, you have to accommodate for that. You have to show that. It is an ion. It is an imbalance, which means that, for instance, this one has nitrogen. Sorry, my mind went blank for half a second. Nitrogen has an atomic number of 7. That means it has 7 electrons and 7 protons. But when you add 3 more electrons to it, it now has an imbalance. It has more electrons than it does protons. Look for the larger number. The larger number tells you what sign it is. So in this case, it's negative. That's what these negative signs mean. It actually gains these, but you have to account for the negative sign. So let's take a look at something. Chloride. We know it is chlorine on the periodic table, but once it takes electrons, it is chloride. So here we go. Chlorine to chloride. It has an atomic number of 17. It has 17 electrons. This is a neutral atom. And if you look at the Lewis dot structure, it has 7 around it. Chlorine, as like a board game, if you're trying to get here, this is the home, it needs 1. So it has a group 7, it needs 1, and you have to have a negative charge to it because electrons have a negative charge. So we can take one spot. There's one spot open here. So it takes 1 electron, and it now is a way bigger circle. So in a sense, it didn't add a floor, it added a bedroom on the same floor. So it spread out, if that's how it makes sense to you. So here, chlorine atom, now chloride atom, and you have to change the ending. So this is now filled with an octet, and it has a negative charge, and you have to show that if I was to ask for a Lewis dot structure. Here, we have 17 protons, has not changed, but we have 18 electrons. Opposite here, you're adding on to an electron configuration. So here we have an electron configuration for a neutral atom. However, we need to add 1 more. So this 5 now becomes a 6. And if you see, we have 3s2, 3p6. That is a filled octet. So this is referred to as a chloride ion or chloride anion. The "ide" ending kicks out this "ine," and that will happen for all of these on this side. This is nitride, this is oxide, sulfide, bromide, iodide. All of these that we use, we're not touching this one here. All of these will have that ending when they are ions. We'll get into naming. Okay, so again, just talked about naming. Here we are. Metals. Metals names do not change. And that makes it tricky. Because of the fact that they don't change, you have to specify the word ion or cation after it. If I just told you lithium, you don't know if you're dealing with a lithium neutral atom or a lithium cation. So I would have to tell you lithium ion or lithium cation. It has to be specified somewhere. And you can see that's what this term cation means here. So when you would say these, you would have to say this afterward, or ion. Now on the other side, you don't have to do that with these. That's the nice thing. When you change the ending to "ide," that means it's an ion. If you leave it nitride, if you leave it as nitrogen, then it's not. It's a neutral atom. But when you change it to nitride, it is now an anion with a 3+ charge. Where did the 3+ come from? Again, it already has 5. It added 3. 3 plus 5 equals 8. You need a negative charge to show that it took in 3 electrons. And that applies for all of these. Notice the numbers first. I know this is a little blurry because I found this online as well. Actually, no, I found this came with the book, but for some reason the pictures just don't come out right. So this is a 3, 3, 2. See, 5a with 3 is 8 octet. 6 plus 2 is 8. 7. All these have a negative charge. They do not have a 1 minus because the 1 is not put in there, because when you have the negative charge, it's defaulted as a 1. And here's all the names for them. So oxygen loses the YGEN and it becomes oxide. Magnesium oxide, something like that. Now, ionic charges. This now is spelling out the valence electrons. Metals lose electrons. So you can see group 1 all has a plus charge, and it is in the upper corner, not next to it. Magnesium has a 2, so you write it 2+, 2+, 2+, 2+. Aluminum, here it is. Even though it's not always discussed, here it is. Al3+, group number 3. Nonmetals gain valence electrons. A 3 minus, 3 minus. Noble gases have nothing. And then here, 6. So that means it needs 2 to make 8. 2 minus, 2 minus, 2 minus. This is selenium. 7 needs 1. Fluoride, excuse me. See, I haven't caught myself. chloride, bromide, iodide. And then here's the chart again. If this confuses you, I strongly suggest that you get a periodic table. I have them here. You print it out and write all this information. Write on it. I had a student that did very well in a harder upper chemistry class. And one of the tips that he gave students was that he had a periodic table. He had his, what he used for studying, and he wrote important notes with everything he needed, so he could always refer back to it. Now, we're at home right now. He wouldn't be able to do that if during a test, but during studying, this could help him. So if this doesn't make sense to you, get a periodic table and write all this information out. Write it out, because writing it out helps you understand and retain it. And the word nada, nada here means that nothing's going to happen to this one because it already has 8. That's all. So nothing. Okay, so here's, this just gave me a little slide to show you why we have ions in our body and what they do and what they need. I used to be a runner for 20-something years. My knees are completely gone now. I've done marathons and so forth. You wouldn't know it, unfortunately, looking at me now. That's what age does. But I love pickle juice, and it's the salt. I need the salt because when you run a lot, you lose all of those electrolytes and stuff. And no, I don't touch Gatorades and any of that. I love salt. I love the pickle juice. It's really good after workouts. So that's my thing. But you can see what other things here, calcium, magnesium, and so forth, why you need to know about this in chemistry. Because some of you are asking, why do you need to know this? This is why. It can start being related to understanding health and your body. All right, so here's something I could give you, and you would need to understand this. Take your time. Do not panic when you read this stuff. I know it's very normal, but you're fine. Write the formula and symbol of an ion. So keyword there, pay attention, ion, with 16 protons and 18 electrons. Let's say I didn't use the term ion. You would have to know that this is an ion. How could you know that? Because there's 16 protons and 18 electrons. They are not balanced. That instantly tells you this is an ion. Now it's up to you to determine, is it a metal or a non-metal? How do you do that? Well, look at the larger number. The larger number is going to tell you what it is. If it has more electrons, it's a non-metal. If it has more protons, it's a metal. Okay, so I'm going to cheat and jump ahead to explain this. Protons, 16. So let's go down here. Here is a 16. So this is sulfur. It is a non-metal, and it's got 6 electrons to it, valence electrons. It needs, as a board game, 1, 2. It needs 2 plus 6 equals 8. So because it's going to need 8, it's going to have to take in 2 electrons. So if you take in 1 electron, it gives it a -1 charge. You take in 2, it gives a 2 negative charge. So it's going to have a charge of 2 minus. And it's going to have the sulfide ion. If you write it out, it has to be sulfide ion. This is sulfur. You will drop the UR and you will add IDE. So it's a sulfide ion with a 2 negative charge in the upper corner. All right, so let's do another one. This is now, well, I'm going to break this down into steps that it is, because I really can't discuss it without showing it. Consider the elements of calcium and chlorine. Identify each as a metal or a non-metal. Let's just take them one at a time. We're dealing with 2. So the first thing I want to do is figure out, is calcium a metal or a non-metal? It is on this side of the periodic table, so it is a metal. Chlorine is on the other side. It is a non-metal. So we can take care of the first one. Second one, state the number of valence electrons. Calcium has a 2, so it has 2 plus, 2 valence electrons. Chlorine has 7, and as a board game needs 1 more, so it's got 7 valence electrons. If you didn't have the periodic table, you have the ones, you just subtract these by 10. That's all you do. Okay. C, state the number of electrons that must be lost or gained for each to acquire an octet. So calcium, as a board game, goes backwards, 1, 2. It will lose 2 electrons to acquire an octet. Chlorine, as a board game, will go forward 1. So it will take in an electron. So it needs 1 more, because 1 plus 7 equals 8. 1, 2, 2 plus 6 equals 8. Do you guys see a trend here? Nitrogen has 5. 1, 2, 3. 3 plus 5 equals 8. So here, chloride, now it's chloride because it is an ion. Oh, sorry, jumped ahead. Chlorine will gain 1 electron to gain and acquire an octet. Once it takes that electron, it's an ion now. You have to change the name to chloride, not chlorine. And that will have a Cl minus, and calcium will be a Ca2 plus calcium ion. This will take a little while, can be a little overwhelming, but you read this, make sure you understand the foundational steps of this here, and you can use it for all the other elements as we go on. Okay?